We are now going to look at binary covalent compounds. Binary covalent compounds, binary means two elements. Covalent will be nonmetal with nonmetal. There are two types of covalent compounds, inorganic and organic. We're going to do inorganic. Inorganic are compounds that do not contain carbon, generally, except for carbon dioxide and carbon monoxide. Organic compounds contain carbon, hydrogen, and often oxygen, nitrogen, and some other things. We are not going to do organic. Organic has its own naming system, nomenclature system. We are just going to do simple covalent, inorganic covalent compounds, simple meaning the binary ones. So two elements only. When we write the formula and name them, we start first with the more electropositive element and then end up with a more electronegative element. Fluorine is the most electronegative element that we have. It's in the upper right of the periodic table, excluding the noble gases which do not react. As we move away from fluorine, we get slowly more electropositive. So on the right of this list, left side of this list, carbon is a more electropositive element. Right side of this list is a more electronegative element. So the most electronegative is fluorine. Next to it is oxygen, which is just left of it on the periodic table. Next to it there is chlorine, which is right below fluorine on the periodic table. So as we move away from fluorine, we get to be more electropositive. So we start off listing the electropositive and then the electronegative elements. So what we're going to do is name the electropositive element and then the electronegative element. And the second element, we're going to change the ending to IDE ending. And this is just the same way that we change the ending on the anion of a binary ionic compound. So it's the same convention of turning this more electronegative element into an IDE ending. But with these compounds, there can be a variety of combinations that we can get with any two elements. With sulfur and oxygen, there's at least a dozen combinations of sulfur and oxygens that we can make. The general form for the environmental term is SOX. So sulfur oxygen with a subscript X, which means it's variable. So to identify the appropriate compound, we're going to use prefixes to identify how many of that element is present. The prefixes for one is mono, and we rarely use this one, just like we rarely use the number 1. 2 atoms would be di, 3 tri, 4 tetra, 5 would be penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. So we do not use the prefix mono much. We do not use it on the first element ever, and on the second element we use it when necessary to prevent confusion of names. So the two common ones that we'll see with the prefix mono are going to be CO. So we're not going to use it on the first element, so this is going to be carbon. The second element, oxygen, will become oxide, and in this case we use the mono prefix. And it won't be monooxide, but it will be monoxide. So CO is carbon monoxide. NO will be nitrogen monoxide. NO has a Latin name, nitric oxide, so that's another one that you may see. So CO2, carbon dioxide. We don't use the mono on the carbon, but we're using the di on the oxygen, carbon dioxide. pH3, phosphorus trihydride. Hydrogen is second, so it gets the IDE suffix on it. NH3. This is ammonia. The systematic name would be nitrogen trihydride, but this is a common chemical, and we will use the common name ammonia. H2O. Well, we know this is water. The systematic name would be dihydrogen oxide. Another version would just be hydrogen oxide. But we're just going to call it water. We're not going to worry about those other names. SO2, sulfur dioxide. IF6, iodine hexafluoride. Br3O8. So we have a subscript on our first element here. So we're going to start off with a prefix. So that'd be tribromide octaoxide. Cl2O5. Again, we start off with the prefix dichlorine pentaoxide. HCl will be hydrogen chloride. HBr, hydrogen bromide. HI, hydrogen iodide. So we're going to have to be able to take a formula and write the name for binary covalent compounds, or take the name and write the formula. Either way, we should be able to go either way with this. Now the two on the bottom here, hydrogen chloride, hydrogen bromide. Well, the hydrogen is listed first. Water, the hydrogen also listed first, but water won't apply. But these where the hydrogen are listed first, these will dissolve in water, and in the process of dissolving in water, release that hydrogen. That hydrogen is more electropositive, which is why it's listed first. And in water, water will react with this and extract that hydrogen from it, creating a H plus ion, or the water H plus will attach to water to create H3O plus hydronium ion. So we have a series of covalent compounds that will dissociate, releasing H plus when they're dissolved in water. These compounds, the hydrogen is listed first, which shows the more positive of the two elements. And when we dissolve them in water, we change their name from a covalent name to a acid name. So for binary acids, which is hydrogen with one other nonmetal, we need to see that it's in water to give it an acid name. So we want to see that AQ physical state, aqueous physical state, to say that it's an acid. If it's pure as a gas or liquid, it's a covalent compound and gets a covalent compound. So HCl as a pure gas would be hydrogen chloride. But dissolved in water becomes an acid. So for our binary acids, we're going to start off with the word hydro as a prefix. We're going to go into the root of the nonmetal, chlorine, but we're going to change the ending to an ic ending, and then throw the word acid after it. So chlorine becomes chloric, so it becomes hydrochloric acid for HCl. HF in water is hydrofluoric acid. HBr in water is hydrobromic acid. HI in water is hydroiodic acid.